So I would suggest that all the speakers also do the same and show, so we want to see you, of course. Actually, this was a very interesting session because if you think in a normal conference in networking, we had as much as 6 papers, over 26 accepted, dedicated to security and privacy issues, which is probably showing the importance of those topics also in our community. I mean, it's not anymore the specialized topic of security conferences, but also in our conferences actually are getting a lot of papers on that. And also we have the best presentation award in this session. Actually, I encourage you to see that presentation because it was very, very beautifully conducted as a dialogue. It's really interesting. So if every speaker wants to introduce himself, and then we have a couple of general questions and we can move to more detailed questions.
Yeah. Giuseppe, just let me add one thing. Like in the previous session, we are going to get questions by the audience by the chat. So if you have questions that you want us to repeat aloud, just write in the chat for everybody that is listening.
Okay, so I see Cristiana, Gustavo, Marco, Charles, Giorgio,
Fernando.
Giorgio, show your face. Anyway, let's start in the order. So the first paper was from Charles.
Hello, I'm Charles Gonçalves. I'm a PhD student from University of Coimbra. And the main focus of my research is the security of virtualization infrastructure, with the focus mainly on the hypervisor. Currently, we are interested in create a security benchmark for hypervisor.
Okay, thanks. Then Gustavo, I see.
But Ananda jumped in, so she can take over.
Ananda, maybe that you can take over.
Hi, I'm Ananda. I'm a PhD student from Federal University of Rio de Janeiro from Brazil. And my research interests are on multi-way analysis and network performance evaluation.
Okay, then we had Cristiana. I see you, right?
Hi, I'm a postdoc researcher at the University of Cyprus and RISE Research Center in Cyprus. And I'm currently working on intrusion detection systems in the Internet of Things.
Okay, for the fourth paper, who is going to present?
Okay, so I can quickly present myself. So I'm Gustavo. I'm a PhD student here from UFRJ, and my main research interests are artificial intelligence and network performance evaluation.
Okay.
Thank
so
you,
for the
Gustavo.
fourth paper, let's go to Marco Cominelli then, that I see you.
Yes. My name is Marco Cominelli. I'm a PhD student from the University of Brescia, and my research interest focuses on wireless communications, mainly on security aspects and other things like localization in wireless networks, always targeted to security and privacy aspects. Thank you.
Thanks. And then the last paper was Giorgio or Francesco. Giorgio, probably.
Hello. My webcam doesn't work, so
You can just talk.
Okay. So good evening, everybody. My name is Giorgio Bernardinetti, and I am a PhD student from University of Rome, Tor Vergata. My research interest focuses on cybersecurity and machine learning. Thank you.
Okay. So I would start with a very general question that is for all the speakers, or at least for those who need to evaluate the performance. And that's actually a problem, in my opinion, in security. I actually looked in your papers on seeing how you evaluated the security, because the problem is that it's very easy to evaluate performance. I mean, in normal works in networking, you basically you do your evaluation and so on. But for instance, in your cases, you have to emulate the attacker or basically emulate the anomalies. So I believe that there is a detach with respect to reality. What's your point on this? That is how to be as most convincing as possible that you are evaluating something that is real and not just some artifact. So everybody is free to comment, because I guess it's a general problem.
So I think I can start. So in our work, we consider two different scenarios, right? First, we consider network performance evaluation, considering network events. In this scenario, we consider only real things that happen For example, in the presentation, we show an example where we detect an attack, or we detect the performance improvement due to an equipment change. So in this scenario, we consider only real things that happen. On the security scenario, we have a bit of more challenges, but we plan to address it in two ways. First, we are buying Raspberry Pis and distributing it across different homes, so we can generate the attack using the real code from malwares that are used for IoT devices, and we will be able to collect the real traffic that is used during the attacks and try to detect it. We are doing some preliminary things like that, but the pandemic made everything more harder, right? And we also have some evidence in our data that we are currently collecting that some attack was performed and we detected with one of our methods. So we can also, as we are always measuring multiple users, we can always look at our data and see, oh, it looks like we had an attack, we detect something here, and then we investigate and try to correlate it with a non-attack that happened.
What about you, Charles? In your case?
Yeah, in my case, it's a little bit difficult because we are trying to explore a security approach. When a user acquires a legally virtual machine in a cloud environment and legally explore some vulnerabilities in the environment, we try to search for a proof of concept for any kind of attack that can be used to exercise the environment to be a more representative. But it was too difficult. In the end, we tried to explore a resource exhaustion pattern. And when you are focusing on evaluating the security, it is really complicated to explore on a representative attack. And this is our main focus right now, is to find a proof of concept or maybe explore an open issue in the virtualization infrastructure to have a more representative attack. It's really difficult.
Yeah, actually, the same question for Christiana, because in your case, what I saw is that you basically are doing sinkhole attacks, so attacks to the routing systems of IoTs. But also in that case, it's not so easy to find out a realistic model. So what's your take on this?
We actually implemented the attack because we thought that it would be more precise how to show that our methods worked. So yeah, basically we implemented the attack to do that. In operating system, then we implemented one of the methods for the detection system. Now, the hard question is how to find traces to apply the methodology to detect the attacks. I'm hoping the near future that traces will be available for the network security research for the Internet of Things that everybody can use. The hardest part, though, is to provide the data needed for every detection model to be able to use. For instance, we actually use network parameters in the network layer of each sensor. So yes, my thought is that if it was an available traces from the attacks that everybody can use and apply that method, will be much easier than actually implementing the attack.
Okay, thanks.
Yes, if I can add something to this question, there are I think 3 works on anomaly detection, and there have been quite enough research in the last few years dealing with this. Also because we have a lot of research on machine learning, we have a lot of data analysis, and sometimes I'm not in that field. I wonder what are the challenges that can make these 2 fields, machine learning or in general data analysis, and security and networking together. Sometimes most of these works, they try to optimize something in a very precise way, but the internals of the instruments are really hard. So what what is your take on this? What do we need? Do we need more precise algorithm? Do we need more precise data? Do we need more real-world experience? What do we need to make this anomaly detection, in a sense, closer to the product and still research relevant?
I think it's real data will be more precise for anomaly detection, but the disadvantage of the anomaly detection method is that it's environmentally specific. So real data for a specific environment can be used for only one detection model. I mean, for when it comes to if you are monitoring an environment with human interaction, I think the AI will be most probably more appropriate to detect the attacks because it has to learn first. So I think the challenge is that with anomaly detection, it relies entirely on the environment, and it requires training and monitoring period that you assume there is no attacks there before you actually apply the detection models.
Yeah, so I think I agree with her, and I think that as we move towards artificial intelligence methods, the data is essential. You have to be good quality data to be able to train the models and improve their performance. And so in this scenario, it's essential to monitor continuously the network in order to be able to detect these events, to have data about the events, and then train the models. And I can say from our experience that it can be hard at times to get these labels of when something happened. So, for example, we have monitoring the data here in Brazil of multiple homes, and sometimes you can detect something, but it's not as easy to detect and then say, oh, that was what happened. So it's a challenge, but I think that as we get more and more data, our algorithms will get better.
And if I can,
sorry, go.
Just want to add some comments regarding those questions, because I think another aspect that is difficult in this anomaly detection world is to define precisely what are the requirements of your environment to which approach should you use to determine which anomaly are you trying to detect. Because if you are using machine learning and AI algorithms, you have some challenges. At the same time, you have some techniques, as we presented in our papers, that try to avoid some prerequisite requirements regarding which kind of data we have. We are trying to learn some common patterns in the environment. So just to conclude, I think another difficult aspect is to determine exactly what are the requirements of the environment that we're trying to use the anomaly detection technique. This is sometimes too difficult also.
Thank you. By the way, there is a question from the floor to Marco. Marco, can you read the question, or did you see it?
Yes, I saw the question. Can I respond, or maybe Michele wants?
Yeah, just let us repeat it, because not everybody can read the chat, at least in the session. So it's the question is about the fact that if the results are specific to the GPU that you have been using.
Yes, thanks for the question. I would say that our solution is very easily portable to other GPU models, but it's pretty specific to the GPU brand. I mean, it's not really portable to other manufacturers. And the fact is that we implemented our solution on NVIDIA GPU using CUDA, that is a language developed by NVIDIA, and it's not supported by other manufacturers. So while in principle the idea behind our implementation can be ported to other platforms, it's not immediate to do so. While for the specific GPU model, basically you're only limited by the computing capability of the GPU. So even if you have different models, but with a least value in their capability, then it's immediate to port it. And yes,
by the way, sorry, Marco.
Yes.
Just to remember, because maybe that not all the people here have read your paper. Marco is talking about Bluetooth Low Energy Sniffer. And actually, they did a very impressive work in how to basically monitor. I don't know whether you want to introduce at least the context so everybody can understand what you did.
Yeah. The context is that, well, we find ourselves pretty limited in the world of Bluetooth sniffing because, as you may know, Bluetooth uses a frequency hopping spectrum technique to access the medium, the channels. And most of the open source sniffers available are able to sniff only just one channel. So we overcome this limitation by looking at all channels simultaneously, developing a full band sniffer. And the only way that we found to cope with the high amount of data that is coming from this wideband radios is to offload the computation, the radio computation, to a GPU. And so that's the reason I was talking about the different GPU models and the core of our work. And
sorry, another curiosity. It's COVID time, and Bluetooth is becoming the prime technology for that. Did you sniff some immune applications, some of those? So what are the? I saw also the Brazilian guys. Actually, you presented your paper in the Best Presentation Award by talking about COVID, the anomalies. I mean, they detected anomalies in the traffic. Probably you are detecting also a Bluetooth increase. So I don't know whether you notice it or not.
Yeah, for sure, Bluetooth became really popular in the past few months, thanks to many contact tracing apps. And yes, we didn't test it on the Immuni app, or we didn't go around checking for how many people were now going around with Bluetooth on. Maybe it's something that we can.
How many downloaded the app?
It's legal.
Legal. Now, instead, I wanted to come back to the paper from Ananda and Gustavo. I saw that you used a technique that I was not aware of. It's called tensor decomposition. Basically, it looks to be a generalization of PCA. I mean, we know very well, probably as a community, PCA, but at least I didn't know about it. So why it's needed, this kind of generalization? Why PCA is not enough?
Well, it's about the structure of the data. With PCA, in our case, we use the tensor, right? And we had a dimension of users and a dimension of measures and time. And with PCA, if you want to use all this data to analyze, you have to use all these matrices together in one big matrix. And sometimes, in this case, you lose structural information in the sense that you don't get the relation between the metrics and over time and for all the users. It's more like it's a way to account for these relations between metrics, relations between users, and relations between time altogether. It's more on that direction.
Yeah, I thought it was very interesting.
But I have a couple of questions for Giorgio that I think you didn't speak yet. Giorgio, are you there?
Yes, I'm here.
Yeah. So my question was, well, I have a couple of them. The first, it's really general, and it's like, how can it be that in 2020 we are still facing a problem with reply attacks based on counters? We have been going through this for latest, 30 years. And I hope that at least that in this case there are some constraints that made this possible, that they couldn't actually make it in another way. The second question is more about the fact that apparently the system you described is made of those kind of passive devices. I mean, devices that you cannot really operate on. and they are going to be there forever. And it's even hard to imagine that they can be replaced or reflashed or something like that. So the question was, are we going toward a situation in which we're going to have like hundreds or thousands or hundreds of thousands of zombies that can be actually exploited from somebody else, and they will never be reflashed or upgraded? Or is there some kind of, I don't know, over-the-air upgrade that we can use in that specific technology?
Okay, so for the first question, the real problem is that the protocol left the counters details to the implementation. So they never specified how to cope with the counters and out of order packets. And as a matter of fact, the device vendors implemented the counters in a volatile memory. So even if the protocol states that you should drop out of order packets, because the memory is not is volatile, when the device reboots, these counters are lost. So the real problem is not that we don't know how to cope with the counter problems. The real problem is that the protocol didn't say anything about it in the specification, and the vendors implemented custom solutions, let's say. And for the second question, yeah, you described exactly what the real problem is, because when these passive devices disconnect from the network, they are effectively zombie devices. So the only way to actually recover them is to physically go to the place where they are and manually flash an upgrade, a firmware upgrade. Even though if the devices are working with the old protocol version, which is the one of our paper, so LoRaWAN 1.0, they cannot be upgraded to the safer version, which is LoRaWAN 1.1, because the hardware capability of the devices are completely different. So once the device is let's say zombie, it has the possibility to remain a zombie for the rest of its life.
Okay.
Thank you for this encouraging answer.